Okay, class, you know the drill. I'm just going to do a quick run through here so you can press pause if you need to slow down or rewind if you need to repeat something, but here we go. A function is always a relation. A relation is sometimes a function. Number two, if we want to evaluate, we're going to plug -2 in for x, right? We're going to substitute that. So whether you use a calculator in your head, right, -2 times -4 is +8. 8 minus 7 is 1. If we plug in -5, we'll have -1/2 times -5. Two negatives make it positive, so we'll end up with 5/2. If you use a calculator, you might need to change the form of it to make sure. Number 4, for plugging 2 in, the negative does not go in the parentheses because that's just part of what's already there. It's not part of what we're plugging in. We'll end up with -7. If we write a function rule that gives the total cost, COP of pounds of sugar, if each pound is 59 cents, right? It's 59 cents per pound, right? If it's per item, it gets the variables, so we want D. Okay, 6 through 10, we're gonna plot points here. So we'll plot the point 4, 2. 1, 2, 3, 4. Make sure we label it. B is -3, 3. C is 0, 5. D is -3, -2. And E is 2, 0. Make sure you're okay on 8 and 10 on C and E, because those were some of the most points missed on the quiz of just getting those flip-flopped and backwards. Domain and range, right? We can't list any repeats. They have to be in numerical order. They have to be inside braces. So our domain is going to be 3, 4. We're not listing that 4 twice. Our ranges are Y values, so -1, 2, and 5. 12, our domain is -3 and 4. Our range, let's see, is going to be 4, 7, and 8. 13, when we're completing our mapping, right? Numerical order and no repeats when we're putting these in. So -3 and 4. Let's see, 2 and 6. -3 goes to 2, -3 goes to 6, 4 goes to 2, and 4 goes to 6. 0 to 6, -5 and 6, 6 to 6, 2 to -5. Inverse, we are just switching our x and y position. So we have 2, -3, 6, -3, 2, 4, and 6, 4. We'll have, let's see, -5, 0, 6, 6, -5, 2. Number 17, they say that the instructions say to solve for y and to rewrite it in function notation. So our x and y are together, so we're going to move that 12x first. And we'll divide by the -3. Okay, but when we go to write our final answer, we want it to be in function notation, so we'll want f of x equals 4x minus 6. Okay, number 18, our x and y are together, so we're going to move that 9x first. Divide. And then function notation. Number 19, we're going to start plugging this in. Start plugging in numbers so we can graph it, right? So no fraction. So we can plug in 0, 1, and 2 here. So 4, 7, and 10, right? I'm doing 3 times 2 plus 4. I'm going to plug those points. 0, 4, 1, 7. 2, 10. I'm making my line. Number 20, we need to solve for y first. right? We always want this to be in our function rule format so we can pick good input values. No fractions, so we're safe just picking 0, 1, and 2 to start with. Here's our line. Number 21. And we have to solve for y. Right, there's really a 1 sitting in front of that, so we'll get positive 1/2 x minus 1. So when we do have a fraction, right, we want 0, the denominator, and a multiple of that. It could be -2, right, as long as it's not giving you a fraction output. Mm-hmm. 22, we're going to plug these all in and check them, right? So our x value is 10, our y value is 0. So if I say y equals 10 minus 4 times 10, so 10 minus 40 is -30. So this would be 10 comma -30, but that's 10 comma 0, so that's not right. Okay, so then we'll plug in 0, so we'll say 10 minus 4 times 0. 10 minus 0 is 10. We plugged in 0. We got out 10, so that one's right. Right, 82 is not 2. Number 23, I would solve it for y first. Again, that's just the format we prefer. It's easy to plug in. So if we plug in 1, plug in 3, all of those end up working. 24 has a repeat, so this is not a function. 25 does not have a repeat, so it is a function. Right, only one line each, so this is a yes. Vertical lines only touch once, so that is a yes. 28 we're gonna plug in. So let's see, 1.5 minus 1 will give us 0.5. 3 times -8 minus 1, -25. 3 minus 1 is 2. This goes in the g function. 9 minus 3 plus 1, so 9, 6, 7. 4 minus 2 is 2, plus 1 is 3. Okay, so a -1 squared is a +1. These two negatives make a positive, so we'll get 3. So 4 plus 2 plus 1, 7. -13. Okay, the graph at the right represents Sam's typical school day. What do the flat sections of the graph represent? This would be a constant distance from school, so we need to talk about that. Total distance over time and total distance from a location, right? Our total distance can't return to 0. 38 if we start solving this. We'll divide by -6. Remember, when we divide by negative, we have to flip the inequality sign. 40, let's see, area, so we need to multiply, so I'm gonna use a calculator here, times 12.5, gives us 51.625. Don't round because it doesn't ask us to, or you could change it into a decimal, so 51.625 centimeters squared. Graphing. This is gonna be an open circle and shaded to the right.